This lesson is going to investigate geometric sequences, and we're going to solve a couple of questions about geometric sequences, but first, why don't we figure out what one is? A geometric sequence is a sequence of values, and typically they're integer values, and to move from one term to the next, we multiply by a value. Now, remember, if you multiply by a fraction, so for example, multiplying by a half, is the exact same as division. So the geometric sequence could divide the values, so the values could be getting smaller. But if you just want to think of it as multiplication by a fraction, then we are always multiplying. We are told in this geometric sequence that t1 equals 2, so that's the first term right there. So we're going to start at 2, and this r value is 3. Now what is r? Well, r is the common ratio. And this is the value that we are going to repeatedly multiply by to produce all of the other values. So how do we go ahead and do that? Well, let's take a look at this. The first term, we are told, is 2. The common ratio is 3. So if we multiply by 3, we are going to get the second term. So, all right, t2 is, well, 2 times 3 is 6. If we continue that pattern, then the third term is going to be the 6, again, multiplied by 3. And that means we're going to get 18. The fourth term here is going to be 18 times 3, which is 54. And we can just continually multiply by 3, and we can see that we keep getting more and more values in this geometric sequence. So if I go up to T7, and then we go to T8, is 4, 3, 7, 4, we can see how these values increase, and they're always being multiplied by 3, and that gives us the next term in the sequence. Okay, well, that is one way for us to find the fourth and the seventh term here, because the fourth term is right there, and the seventh term is right there. But there is an easier way, other than listing them all out, because we might get the question, find the 100th term, find the 300th term, and we certainly can't be multiplying these out and listing all 100 terms in order to find a specific one. So why don't we use the formula, and that is the general term for the geometric sequence. Okay, so this is the general term of a geometric sequence. And all we need to know is we need to know what term we're looking for. And A is the starting value, or T1. So this would be the A value right there. R is the common ratio. In this case, it was 3. And then N, again, is the value that we're looking for. So if we're looking for, in this case, the fourth term, we can go directly there by just saying T4 equals A. Now, A is the first term, which is 2. R is the common ratio, which is 3. And we're going to raise that common ratio to the value of n minus 1, which in this case is 4 minus 1. Solving, we get 2, 3 to the exponent. 4 minus 1 is 3. And remember your bedmass rules here. We're going to take care of the exponent before we do the multiplication. So 3 to the exponent 3 is 27. 2 times 27, 54. And we can see that that definitely matches the fourth term. Okay, so we could go ahead and solve for the seventh term in the same way, the eighth term, the ninth term, but that's how we can go and get an exact term by using the equation of the general term. Let's try a question that's a little tougher than that. Okay, in this question we're asked to find the first 3 terms in the geometric sequence, where the fifth term is 162 and the ninth term is 13,122. So in order to find the first 3 terms, we need to know the actual first term. And in addition to knowing where we're starting, we also need to know the common ratio. Because we're told this is a geometric sequence, we know that we're going to have a common ratio, a value that through repeated multiplication is going to allow us to move between the terms. So without either of those pieces of information, we have to do a little bit of figuring out first in order to get the answer. So let's see what we're given as far as information. We're told that the fifth term is 162 and the ninth term is 1,000, or rather 13,122. So through this, we should be able to determine the common ratio. Well, let's see how we can figure that out. Well, to go from the fifth term, which is 162, to the ninth term, which is 13,122, well, we had to go through 4 repeated multiplications of the common ratio. Okay, so that means that we had to go through sort of 4 steps of repeated multiplication. And then to get that, then that multiplication produced, it turned 162 into the value 13,122. So how could we write a little equation to kind of describe what happened? Well, we could just say that, all right, 4 repeated multiplications of the ratio created 1,000 or 13,122 divided by 162. Okay? And that would mean that 4 repeated multiplications had the same effect of multiplying 162 by 81, which, again, because it's geometric, it turned 162 into 13,122 through multiplication. And then can we solve for r? Well, easily. We can just take the fourth root of both sides. So the fourth root of r to the fourth is going to be r, and the fourth root of 81 is 3. So now we know that the common ratio here is 3. Well, how can we use that little bit of information to help us? Well, if we recall that the nth term of a geometric sequence is this equation here, ar to the n minus 1. Well, what we need to solve for here is we need to solve for a, that is the first term. So we can use this information to go ahead and solve for a. And the a value is the first term. So let's use either the information from the fifth term or the information from the ninth term to go ahead and solve for a. And I'm going to use the fifth term because the number's a little smaller, a little easier to manage. So let's take T5 then. And so we know that the fifth term was 162, and that's equal to the starting value times this common ratio of 3 times n minus 1. Well, we know that n is 5, so 5 minus 1. That means that 162 is equal to a times 3 to the exponent 4, or 162 equals a times, and 3 to the exponent 4, well, we know that 3 to the exponent 4 is 81, and that means that 162 over 81 equals a, or a equals 2. So the first term was 2. Well, using our common ratio, we could then figure out that the second term would be 2 times 3, which would be 6, and the third term would be 6 times 3, which would be 18. So that would show us how to solve for a, and then with that we can find the first 3 terms in this geometric sequence. Okay. Now just before we finish, let's go ahead and revisit the solution where we solve for r right off the bat. We could also solve for this algebraically using the two terms that we have, T9 and T5. And what I could do is, now that I recall this general term, I could have said this. I could have said, okay, well, 13,122, that's the ninth term. So that should be equal to A times R, and to the n minus 1, well, this is term 9, so n was 9, or r to the 8th power. Similarly, with the fifth term, I could write the same thing. I could say, well, 162 is equal to a times r, and in this case, n is 5, so 5 minus 1 is 4. And there's my two equations. Now, if I divide these two equations, I get 13,122 divided by 162 equals a r to the 8th divided by a r to the 4th. And how does that help? Well, the a's cancel out, and I'm just left with r's. And if I recall my laws of exponents, I know that r to the exponent 8 divided by r to the exponent 4, well, that's going to be equal to r to the exponent 4. And 13,122 divided by 162 is 81. And we are right back where we were as far as the equation to solve for the common ratio. Okay, so if you'd rather do it algebraically with the two equations, you can solve them that way. Or if you just kind of reason it out and say, you know what, to go from 5 to the 9th term is 4 repeated multiplications of the ratio, so that's r to the 4th. And how did we turn 162 into 13,122? It was through multiplication, so to undo that, I would just divide. We can also solve for the ratio. So there are two questions, two examples that show you how to work with word problems involving geometric sequences.